What's going on? This is OXDF, and I'm looking at Advent of Code 2021 Day 2. Diving in for the first time right now. Let's see. So you've got to figure out this pilot thing. Okay, so it looks like we're getting instructions. Our input is going to look like this. So we're going to get instructions that say forward, down, forward. Looks like basically the three instructions are forward, down, and up. It seems pretty straightforward. You get a final position of 15 and a depth of 10. Multiply them together to get 150, and we get results. Okay, so it looks like I'm gonna have to process those three commands, find a position and a depth, and multiply them together. Let's see what, go ahead and see. So first we will save this test input. Get over to our terminal. M02 example. There we go, looks good. And we'll go ahead and save the puzzle input as well. All right, seems straightforward enough. Let's go ahead back to the terminal. Let's give it part one here. M02 example. Have that up so we can see it. Okay, so let's start making some. Start making our script. So user bin env python 3 import sys. And so now what we're going to do here, we're going to, very similar to previous ones, we're going to open up, we have to read in our input. So it's going to be sys.argv1. Ooh, typing is hard. As a read, as f, we're going to do commands equals f.read lines, and let's see, what kind of processing do we want to do on each line? I guess we'll do it in the loop. So we'll do this in a for loop. I bet we could probably do this in a one-liner, and maybe I'll come back at the end and look at that. But for now, let's just do for cmd in cmds, and we're going to cmd dot, let's strip. So I want to remove that end line from the, move any white space from the end, so I just have the two things, and then I'll split it on space, and so then we will have the let's see, so direction and quantity equals that. So then we probably need to come up here and start with a depth. Position equals 0. Let's do it this way. Position, comma, depth equals 0. And so now all we need to do is, what's the easiest way to do this? I'm trying to think. We could use a bunch of ifs, but we could also just define a, so if we define an array up here that sort of says, compass, I don't know, equals, and we do this and we say, what are our three things? Forward is going to be equal to zero. This is messy. Let's do this. Let's come back here and we'll just do some if direction equals forward, position plus equals quantity. Elif direction equals down, depth plus equals quantity. Elif direction equals up, depth minus equals quantity. Else import pdb.set trace. And all I'm doing here basically is saying I could probably, if I'm confident in my input, I could have just put an else here and subtracted quantity, but just in case something goes wrong and I get a direction that doesn't match any of those three, I'm going to just import the debugger and stop right there, and so I can check out what's going on. So once that's done, I just need to print part one, and that will just be depth times, what was that position? Like that. Save it, and let's go down here and give it a try. Python 3, day 02, and then 02 example. I think we're looking for 150. Oh, we don't like, oh, of course. Qty equals int qty. 150. Let's try it with our puzzle input. Much bigger. Let's go back here and see if that worked. Beautiful. Continue to part 2. Based on your calculations, the planned course does not make any sense. You should read blah, blah, blah. You also need to track third value, which is your aim. Okay. So we'll start it. We'll have a third value that is aim. It starts at 0. Okay, so we're basically gonna have to do the same thing again, but this time the rules are just different. So let's go back here. Yank this whole stuff right here and drop it in. So now we really need 3 things. Position depth aim equals 0, 0, 0. Pull up here. So down increases your aim by X units. So what we're going to do is down aim plus quantity. Okay. Up decreases your aim by X units. So just like before. And now I just need to, let's see. Forward does 2 things. It increases your horizontal position by X units. Got that. And it increases your depth by your aim multiplied by X. So we'll say depth equals aim times qty. Like that. Seems good. I read those instructions very quickly, so let's see if this is actually right. So we got 900. What are we expecting for here? 900. Let's give this a try and see if we solved it that quickly. Sweet, that was it. So we got both there. Let's see. I'm trying to think if there's anything I can do to make this look more elegant. And the answer is probably come down here, and what if I define a function that handles the input? So def parse line, and in this function we're going to probably do basically the same stuff we've already seen, right? So we're going to do that. We're going to get a direction and a quantity. We're going to set that quantity there. If direction equals forward, we're going to do it a little bit different here. We're going to, rather than try to make the decisions about what to do, we're just going to give it, at least starting with the first part, we're going to just try to figure out what we're doing here. So we're going to do if direction equals forward, return qty, 0. If direction equals down, return 0, qty. If direction equals up, return 0, minus qty. I'm not convinced this is going to end up being any nicer, but let's keep playing with it for a minute just for the sake of playing with it. So now, and then I can do my same import pdb.set trace. I don't expect to ever hit here, but if I do, I will now know it. So I should have returned one of these 3 by now. So now for part one, I can start to think, okay, what is, you know, so what does it mean? Now what do I need to do to, if I've got this where I'm going to take a line and it's going to return two values. So now I can do, let's see. So I can start to think about this as a list comprehension. Do line for line in lines. So I already read that in earlier. Now for each line, I'm going to parse the line. So now I'm going to have a list of tuples. And so for the first challenge, I just need to basically add them together. Is that right? See, this is probably a good point where I would come and play with it anyway. Do that. So I didn't need the PDB. I could have just put a -I. So let's see. Let's see what this starts to look like. Hopefully I'm using example input. Oh no, that's gonna be way too much output. There we go. Let's switch back here to a -I just for the sake of not needing PDB here. And okay, so now let's see. What does this give us? Lines is not defined. Did I not define? Oh, commands. Okay, so now I have that does not look right because line doesn't exist. Wait, no, yes it does. For command, I mean, this doesn't matter, but let's fix it. That looks fine. So if I do parse line cmd sub 0, I expect to get back 2. That is not what I expected to get back. Okay, it'll help if I name my variables correctly. So I'm doing, try that. There we go. That looks better. That looks better. So now what I really want to do is just, I want to sum all these together. Let's see, can I, no, that's not what I needed. So what do I want to do here? I've got my list of things. I need to map. I guess one of this is where I can use a map. Sum onto that. And I don't want to, there, like that. See what that looks like. So that went through and summed these together. Or summed 5 and 0. It summed each element, and that's not exactly what I want. I wonder if I can pass. Let's try what happens if I do that. I wonder if I can zip that. I'll explain exactly what I'm doing here if this works. 1510. I think that was right. Okay, let's talk about what that. That's cool. That'll work. So let's see what I did here. When I have, let's see, make this simpler so I can show what I'm doing. I think I need that. Okay. With no thing there, when I pass it to zip, let's get back to our clean state. So I've got this list of tuples, and if I pass that to zip, just as it is, then it's just gonna take each. It's taking it's got one list basically. It's just saying, oh, you gave me one list of things. I don't know how to zip one list of things, so I just zip really expects more than one. So you give it two lists, and it takes element 1 of each list and puts it together, element 2 of each list and puts it together. Well, you just give it one list, it's just returning element 1 as a tuple with no next object, element 2 as a tuple with no next object, and that's not super useful. But when you pass into a function, so I'm going to take zip. When you put star in front of it like that, what the star does, I'm trying to think of the easiest way to explain this. Here, okay, this will work. If I do a print, new idea. let's capture this for a second. So we're just going to call this x for now, so I can stop typing it. If I do print x like that, it prints one object that is this array, this list. If I do a print of star x, it's going to print each. It's as if you pass. It's the same as passing each. It removes the list basically, and it passes into the function each item in the list as if it was one thing, as if it was an argument. So if I have, let's just show another example. If I make a function, def test, and it takes a and b. Actually, it's called def add, and we return a plus b. Really silly function. If I try to pass it, if I try to do add of 1, 2 like this, let's make it y equals 1, 2. If I do add y, it doesn't like this. It's saying, oh, you passed me one. I needed 2 arguments, a and b, and you passed me 1, this array. Now, if I try to do this, it's going to now complain that like, oh, I can't do a list plus an int. That doesn't make sense. It's confused. But if I come here and I put a star here, it returns 3 just fine. And because what the star does is it takes the list and it just basically blows it up into individual items. And so now instead of passing in one object, I pass in 2, 1 and 2, and they got added together. So how does that apply to what I was doing before? Let's go back up here. Basically what I'm doing here is I'm taking all of these. So instead of passing in this one list, I'm passing in each item in X individually. So basically pretend I'm passing in 1, 2, 3, 4, 5, 6 tuples. And now when I zip 6 tuples, it's just going to take the first object from each of them together, put it in one group. The second, put it in one group. And that's it. They all have 2. So that's why when I do this like this, and I need to list it, I get 2 objects back, and it's like this. And so what I can actually do now is I can map, and what the map function does is it takes a function, so in this case sum, and it takes a list, and in this case my list there, and it's going to apply it. So now it's going to apply sum to this object. It's going to apply sum to each object in the list. So it's going to apply sum to this object, and it's going to apply sum to this object, and it's going to return a map object, but I can easily turn that into a list here and see that it's going to return the sum of all these and the sum of all these, which is what I'm looking for. So now down here, what I can do is part 1 equals what's the best way to do this? Like this, I guess. In fact, I don't even want, I want to product these together, right? So I can't remember what's the we'll have to go back here to our sorry, let me pull up my Chrome window with Advent of Code. Python multiply items in list. 4 different ways. All right, Geeks for Geeks, what you got? What is it? Traversal. I don't want to do a loop. Come on, there's got to be a function for this. I don't want NumPy. I don't want NumPy. Is there really not a way? Math.prod. Do I really have to fill in math? Isn't there like a, isn't it? There's got to be a better one. It's from 2012. It's probably old. Let's see. I thought this was going to be a much easier question to answer than it is turning out to be. You'll probably find more reputable reduce function. That might work. No, still func tools. All right. I guess we're going to do it with math. Was it math.prod? Go back and try. All right. Okay, I guess we're gonna import math. That feels unnecessary to me, but fine. So I don't even think we need the list there. Let's do math.prod. Looks like we're lined up right. Let's make sure we import math. And then do part 1. Looks good. All right. That looks good. We could take on part 2, and I bet there's a way to do it. But I'm gonna go ahead and call it today. That was hopefully enough beyond root section there for you. If you're not familiar with my blog posts, often I go have a beyond roots, the section where I've already solved the problem, but I'm going through trying to look for extra stuff I can find. So anyway, this is prettier, and I bet there is a way to do part 2. It's a little bit trickier because it's not going to be it's more state dependent. In part 1, I basically, I can just take all of the depth changes and sum them together. In part 2, I got to keep track of what the depth is when I apply a forward move. And so that's going to be harder for sure. But it's probably doable. So anyway, I'm going to go ahead and wrap up the video. Hope you enjoyed. Thank you so much for sticking around till the end. And I'll be back with another one of these tomorrow.